So, I'm sorry for some delay. I had some technical problems. So, yeah, hello all again. Thank you for the invitation to Siemens Polarion. And I hope you enjoyed the past 3 days, Polarion session days. And hopefully you got a lot of inspiration and new ideas. And now we are also happy that you are with us at this time. I know for some of you it was a long day. And so we are quite happy to have you with us. Let me start. My name is Oliver, and Robert, he will support me today, especially with the questions and hopefully our answers. And yeah, let me say, or let me jump in that we introduce shortly our company. So we are a worldwide leading provider in our market segment, and our market segment is holistic variant management in the field of systems and software engineering. Our customers usually come from the automotive or the defense, security, and other high-tech industries. And our main project, or our main product, our flagship product is Pure Variants. And we are Polarion Siemens technology partners since 2015, and we supply the Polarion Variants engine. Yeah, so please let me start with a question. So why do we need variant management? And yeah, I think this is a quite interesting questions. Possibly you have asked you this question before. I would say it in an easy way because we are facing lots of new challenges. So today challenges we have are, for example, we have a modern world which requires a lot of individual products, so our customer require these products. We have the complexity of product, and this is constantly increasing, especially with software requirements. It's not so much about mechanic requirements, but with software requirements, and especially with the possibilities which we get with software development. This will increase the demand from our customer, and it will also increase the ideas what we can do, how we can manage our products, how we can organize our products, and all these things will lead to a lot of ideas, to a lot of variants, and a lot of different product variants. But we have also the situation that our customer expect more and more improvements along the whole life cycle of their product. So it can happen that a product will change several times in a year because of software updates, over-the-air updates. And these possibilities, they also generate new business models and also new demand there. For example, upselling new features and services. So these all things together require new methodologies. And so from our perspective, there are two main methods which will support these increasing complexity of these kind of products. So one is the system engineering. I think most of you are aware of system engineering, so I don't want to go here in the deep. But there's another one, and this is product line engineering. And from our perspective, this is not so common at the moment. There's also an ISO standard behind this. It's 26580. And to say it in simple words, this is about the reuse and the variability of modular systems or software platforms. And this automatically leads, or the consequence of product line engineering methodology automatically leads to a higher amount of variance. So PLE requires a tool to manage a large number of variants, and this in a traceable and a safe and also in an efficient way. So how can we do that? And there is there is a tool which most of you know, and this is Excel. Excel is still one of the most common variant management tools, but to be honest, is it really traceable? Is it really safe? Is it really efficient when you have such complex products as we talked about before? I don't think so. So there should be another way, and from our perspective, there is a solution where you can work in a systematic approach in 4 steps to make it traceable, to make it safe, and to make it efficient. And this is what I want to show to you, how you can manage your variability within 4 secure steps. So the first one is, we call it a single source of truth. So we put all the knowledge about a product line in a consistent and in a role-based feature model. So this is where you are your product line describing, where you describe all the relations between the features and all these things. In the second step, you connect one or many engineering assets, for example, your Polarion requirements or your test cases, with such a feature from the feature model. In the third step, you configure a variant according to your requested features. And this in an easy way, in a guided, in a valid way. So you have a configurator mask, and you can put your tags and make your decisions. And the system will lead you through the process and will make sure that the variant which you are generating now, that this is valid and that it really works based on all the rules from the feature model. And in the last step, you can do an automatic transformation and you generate the engineering assets, the requirements, the test cases, and so on, which match exactly to this variant, and all connected engineering tools, for example, test cases and so on. And this is a generic approach in 4 steps, which will make sure that it is traceable, that it is safe, and that it will be efficient for you when you're doing that. So now the next question is, what is the right solution for us or for you in this case? So if you ask, what should I do now? What is my right solution? Then I would say it depends. It depends on the situation and it depends on your product. For example, if you have a product like this one, possibly you can give Excel a try. I don't know, but possibly it can work. But if you have a product like this one, a modern copying machine, possibly with an internet connection, or if you have a product like this one, for example, a computer tomograph, then I guarantee you that can't work with an Excel file. So if you have variability in such products and this happens, then you can't be sure that can't work with Excel. So, and the good news for you is that for Polarion customers, we have 2 really good solutions how you can manage the variability of your products. So let me introduce these 2 options to you. So the option number 1 is Polarion Variants. This is fully integrated in Polarion. This is a really big advantage of this solution. There is no other interface. It's completely integrated. And the focus of the product or of the variant management is on the requirements in the test cases, so the assets within Polarion ALM. It is a native integration into Polarion user interface, and is especially for customer who work within this frame. So this is a quite good solution if you have a limited requirements to the variability and if you will remain within Polarion variants. On the other side, we have Pure Variants. Pure Variants is, as I told you, is our flagship product. It's a holistic variant management and it's an independent software solution. And What we are doing in Pure Variants, we centralize the feature model, and we are a data provider for with standard integrations for more than 20 engineering tools, like Polarion requirements, like Polarion test cases, but also MBSE model, software code, parametrization data, and so on and so on. So in this case, Polarion requirements and Polarion test cases are one of more other engineering assets, but you have always just one central feature model. So in addition, we have a wide range of additional features which we don't have in Polarion Variants because they are not needed there. But in special cases, especially large enterprise customers, they have requirements like this. I will show you this on the next slide. Just some examples. For example, we have a feature that is called control parametric variability inside requirement text. That means you can indicate variance in your requirements text. Another thing is support different development life cycle stages of variance. We can do analytics about all the variants. So we have a wide range of analytic capabilities. We can manage variability in complex product lines, for example, system of system. We can work with product lines of product lines. That mean, for example, you have a product line, and then you make a sub product line for a particular market or for a particular OEM customer. And out of this subset, you can define the final products. So you make the variant specification through more than one level. And last but not least, we have the holistic variant management approach. So this again mean Pure Variants is the central feature model. Polarion is a possible set of engineering assets, but we have also other engineering assets with MBSE, with simulation, even with products like MS Excel or Word, or we can send parameter sets to external systems, things like that. So we connecting other engineering assets in the same feature model. Yeah, now I can give you just a short example, just a short view to that. So for example, here you see Polarion Variants, and on the left side, I know it is not the latest version of Polarion, but I think you can recognize on the left side the car light system requirements. This is this project for the car light. And on the right side, for example, for this requirement VM59, you can see the restrictions. So there is a rule, and if someone selects a feature or selects a set of feature, then this requirement will appear or will not appear. And in my second example, this is now the new connector. It is a really, really short video. So you can see on the left side, again, it's a headlight, it's the project. On the right side, Pure Variants. This is a widget, so this is a web service, and you get direct access to Pure Variants, to the feature model and Pure Variants. And now you can make the restrictions here in this editor. So it's more or less the same, but you can see the difference is one time it is included in Pure in Polarion, and in the other example, in this example, we get access through the widget to Pure Variants to the central system. And by the way, a quite similar widget like this one, you get also in other engineering tools like Capella, Cameo, or other MBSE or other engineering tools. It's more or less working in the same way. You have the feature model and you connect your feature model with engineering assets in the particular tools. So now, and if you want to hear more, I know this is a quite a short presentation. It's just to give you an overview, but if you want to learn more or if you want to hear more, there are several options. So you can call your Siemens Polarion sales rep or consultant, and he can make a contact to us, or you can contact us directly by email, sales@puresystems.com, or you can contact me. This is my email contact, and then we can help you. On the other hand, you find also on our website, puresystems.com, you find some short videos about the Polarion connector and some more descriptions about the Polarion connector. And last but not least, if you want to learn more about product line engineering in general and systematic variant management, you can also follow us on LinkedIn. So, and yeah, before we start the question and answer session, I guess there is one question who most of you are interested in. So is it possible to migrate Polarion variants to pure variants? And to make it short, yes, it is possible. And yeah, there are some more details. So in general, if you start with Polarion variants and you realize that you need possibly more advanced features, or you want to follow the holistic approach, you want to integrate also other external engineering products, it is quite easy to import the data, the feature model from Polarion variants into pure variants. So it is an export from Polarion and an import in pure variants. And from this moment, you use this new connector and you get access to your feature model through this uh, um, this web service, which I showed to you in the second solution, and the variant model will be managed completely outside Polarion. It will be managed within pure variants. Okay, so that was 19 minutes. I think we have about 10 minutes more for questions. And so now I would like to invite Robert as well so that we can answer your questions. So, do you have any questions? So just a second. Robert, can you see the questions?
At the moment, I don't see any. Now questions are coming in. Does Pure Variants manage all artifacts outside of Polarion? Yeah, to be precise, what is managed in Pure Variants, what is managed in Polarion, what is managed somewhere else. So in that case, you are using Pure Variants to you build up your feature model in there. You configure your variants based on that feature model by feature selection to define which features of your product line are in a specific variant. This data is managed in Pure Variants and via help of in-tool integrations, like for example with the connector for Polarion. These models are available from within those respective tools. So they are not synced somehow, but they are made available via an UI directly from within Polarion, for example, to be able to connect then those requirements that are variable of your superset of requirements that will not be needed for all of your variants, but just needed for variants that have specific features as part of them. And that establishing of the connection you do in the respective tool by loading the data from Pure Variants directly into that UI and creating the mapping there with in-tool integration support, like Oliver briefly showed with that video. Yeah. And the same we do for other tools. So if you have, for example, Capella in use as well, the modeling workbench, then you can also work with a superset architecture there and connect the variable parts of that architecture that are not needed for all of the variants on functional level, on logical level, on physical level, to features of the same feature models. So that in the end, when you configure a variant, you can generate on the same feature selection done in pure variance your variant-specific requirement test cases in Polarion, as well as the variant-specific architecture for your modeling workbench. So you really know all of these assets are generated based on the consistent knowledge of what goes into the specific variant. And that we do also for other tools. Like, for example, if we talk about simulation for MATLAB Simulink, if we talk about code for controlling variability on file and folder level. So which code parts, which files go of my superset of source code go into that variant, as well as fine-grained variability inside of code files, so we can control the existence of blocks of code, as well as injecting values in all of these places. So like you have features in a feature model, you also have attributes there, which can have a different value for different variants. And that value is then injected at the right places in your requirements and test cases on Polarion side, for example, into your code, if you want to do that, into places of your architecture. So that you have a structural and parametric variability consistently managed across tool borders and asset type borders. I hope that answers the first question. And I see a lot more question coming in now.
Yeah, I think we have to answer it shorter, because you're right, there are really lots of questions. There's one with more than one feature trees, Robert.
Yes, so that's for example one point where our two solutions are different. So if you go with Polarion Variants, you are limited to one feature model for a project. With pure variance connector for Polarion, you have no limits on the amounts of feature models. You can split your features into different models. You can have cross-tree relations between features of different models to say one feature requires another. You can nest feature models, and you can use the same set of feature models to control variability across different Polarion projects. So there are many advanced use cases. I see the question I think means you have some use cases. So maybe let's get in touch and discuss it in more detail. So what your needs are there. So there are many capabilities available actually. The short answer is yes. Another question you want to have covered, Oliver?
Yeah, then the next one is about the reuse strategy.
Yes, okay. So basically it wraps around two concepts. One concept is the feature model itself. So model variability first independently from the actual engineering assets. And then the second concept, have your engineering assets built up as superset assets, 150% containing variable and non-variable parts, like a document containing variable and non-variable requirements, and then map the variable ones to your feature model so that the variability can be controlled by the feature model. This gives you a level of abstraction. Instead of going over 200,000 requirements when you look for what to reuse in another variant, you go over your 200 features that are connected to each other. By each feature selection you make, you get feedback which other features are now needed in combination, which ones cannot be used in combination. So all your engineer's knowledge about interdependency is formalized into a model and is taken into account during variant configuration. And then let the tool detect for you which requirements, which test cases, which architectural elements you need, and let it be generated and be sure it's consistent according to all the knowledge you put in there. So that's the strategy. And also this means you have a single place where you can make changes and then propagate them to those variants in your product line that need them, and you can easily identify the variants which need actually such changes. So you can make an update in your superset code base. You can ask pure variants which variants are currently using that part of my code. Then you know, oh, 5 out of my 20 variants need of an update. And then you generate the update for those 5 variants, and they just receive it. So instead of manually pushing and changes from one branch to another, and even across all different tool levels, ensure that everything is done consistently. You have a lot of automation potential here.
Okay, the next one I can answer, and the next one possibly you, Robert. So it's about PDC modeler. Yeah, you can find a complete list of all the engineering tools which we support on our website. There's Pure Variants, and below Pure Variants, there is a list with all the connectors and also with videos and so on. But unfortunately, PDC Modeler is not part of these standard connectors at the moment. So possibly as an individual implementation, but it's not a standard. Okay, and the next was how are versions of variants managed?
Excellent question. This is definitely important and needed. Yeah. So with pure variants, there are two ways this can be achieved. We allow to store our data in two different ways and have two different workflows that you can choose from. One is storing the feature models and variant models file-based. In that case, they go into a version control repository. Yeah. So like Git, SVN. So in case of pure variants, we support any common version control system and provide model level compare and merge views so that you can, if you want to do that, work in a similar style as you would collaborate on code. Yeah. We also have then comparison of how variants change over time, yeah, on feature side, on solution side, all in the tool, graphical comparisons, yeah, representations of the comparison, sorry. The other option is that you run a pure variance model server that holds the data. In that case, we also implemented version control on the model server so that you can track the different versions of your feature model for your product line and of the changes in the variance over time as well. So important topic. Yeah.
Good. So then there's one more. It's about can we manage historical revisions of work item?
Here, I'm not sure I understand the question right, honestly. What you can do, I can tell you that. Considering you are working like this with pure variants and Polarion, yeah, you can define in pure variants with which baseline of your 150% Polarion assets, or out of which baseline of your 150% Polarion assets you want to generate the 100% variant specific Polarion assets. Yeah, so you have basically a place there where you can decide, okay, these variants shall be based on the following superset revision, and also store that information in the variant model.
Okay, and the next one is again about support of MathWorks System Composer.
Yeah, I see. So for both, there's two actually. So for Enterprise Architect, one is the question. We have an integration, yes. For the System Composer, we don't. At the moment, we are on MathWorks side limited to Simulink, yeah, MATLAB Simulink. But yeah, if that's of interest, let's at least maybe talk. Yeah. What else do we have here?
Yeah, this is the last question.
A link for Polarion asset management as building blocks and reuse variant management. Not sure what this means. Is this a presentation from Siemens maybe, or the link to Polarion asset management as building blocks and reuse variant management to work as independent branches?
Siemens Polarion.
Yeah, okay, that goes to Siemens. That question. Okay.
Okay. So yeah, do you have any more questions? We are nearly done. It's 5:30. So if you have one or two more questions, we can answer that.
Oh, there is one. What is the main purpose of the pure variance model server? Yeah, good question. So compared to working file-based, this gives you real-time collaboration. Yeah, so you can work with multiple users on the same model and make changes in parallel. You also have then capabilities like you can make use of our Pure Variants web client. Yeah, so you can work on all the models from within the browser instead of within a desktop client. Yeah. Actually, you have freedom of choice. If you use the model server, you can have power users that maybe prefer the desktop client to work with that one, while most of the other users, the ones that are mainly working, for example, with Polarion and are mapping Polarion assets to features, they want to prefer to stay in the browser and not install any additional client-based tool. They can work with the Pure Variants web client then and access the model server data via this client. Which also provides read-only licenses for additional stakeholders that just want to get read access to feature models and variant models, see what's there, compare variants to each other without the need of editing them. Yeah? So the big point is collaboration here, collaboration and easy access for stakeholders, for as much stakeholders as need the variability information.
Okay, so I think no more questions. Yeah, Robert, thank you for your support. Thank you for answering all these questions. And yeah, so we would like to thank to all of you. Thank you for your time. Thank you for your patience. And yeah, hope to see you soon again. And if you have any more questions, you have the contact data, just send us an email or contact us in another way. And we are happy to support you with any more questions. Thank you very much. Have a nice evening and see you soon again. Bye-bye.
Thanks. Bye-bye.